Hello, hello. Welcome back to math. Today we're going to be working with story problems. You are going to need your math workbook. You're going to open up to page 56. You're also going to need your spiral because, as you can see, there's not a lot of room to work out the problems in this space. We're going to need to work them out in our journal today. So, pause if you need to. Go grab your journal and we'll get started. So, here's our first one. Zach and Noah jogged 2/5 of a mile and walked another 1/4 of a mile. How far did they go in all? So with story problems, they don't tell you exactly what kind of math that they are. So it's easiest to sketch yourself a picture. Notice I said sketch a picture. It's not art class. We're not making beautiful pieces of work. But, so they jogged. Ooh, they're going so fast. 2/5 of a mile. Then they just walked 1/4 of a mile. And the question is, how far did they go in all? So when you sketch it out like that, it makes it real obvious that it's an addition problem. So how far in all? So we're going to need to add these together. 2/5 plus 1/4 equals something. That's what we're going to figure out. So when we're adding and subtracting fractions, the first thing we're going to look at is those denominators. See if they're the same. They are not. So we need to fix that problem. So can I turn one of these into the other? No, I can't. So the easiest thing is to multiply them by each other. If I do it to the bottom, I need to do it to the top. And now I can rewrite my fraction so that I can solve the problem. So 4 times 5, I don't know if there's enough room there. I'm just going to write it down here, is 20. 4 times 2 is 8. I got some 20ths, which is going to equal some more 20ths. 5 times 1 is 5. And now we have 8 plus 5. 8, 9, 10, 11, 12, 13. Of a mile. We don't want naked numbers. We're doing story problems. Okay, so take a look at the next one here. Mrs. Brown bought a dozen eggs at the store, but when she got home, she discovered that 1/3 of the eggs were broken, so she threw them away. She used 1/6 of the dozen for a recipe. How many eggs were left? What fraction of the dozen was left? Okay, so she has eggs. Egg carton fractions should sound a bit familiar. You used those in 4th grade. So 1, 2, 3, 4, 5, 6. So we have 1/3 broken. She used 1/6. So we're trying to figure out how many is left. Pause here. See if you can find the thirds. Okay, the thirds. We need to cut this into 3 equal sized pieces. I'm going to grab another color just to make it a little easier. So I always extend my cutting lines outside of the box just so that way I can really see them. So now I have 1, 2, 3 groups, and each group is 4 pieces, so I know that's thirds. So these ones are broken. So sad. Okay, now you're gonna try and figure out what a 1/6 looks like in here, but remember, 1/6 need to be of the whole carton, so you're not gonna make 1/6 just with these ones. You need to make it with the whole thing. Give it a try, pause here, and then I'll show you what I mean when we come back if you get stuck. Okay, so like I said, we need to make 1/6, right? Our whole is using 6 pieces. And right now I have modeled 3, but guess what? If I just go like this, now I have 1, 2, 3, 4, 5, 6 pieces. See how I modeled, even though these ones are broken and we've already gotten rid of them, I still have to turn the whole thing into 6 equal pieces. So 1/6 that was used, and used. So the question, if I look back, says how many eggs were left. So how many of these eggs are actually left? Try it out. All right, eggs left. 1, 2, 3, 4, 5, 6. 6 eggs left. And then it also wants to know what fraction was left. Well, I can see that the thirds is not going to work because this one is broken up. So I can say 3/6. I could say 6/12. Those are my two answers that I could pull out. Eggs left. You do not have to have both, but I put them both so in case you got something different, you can have them. Okay. Number 3. Erin had 3 1/9 boxes of granola bars. She gave 1 3/4 of the boxes of granola bars to her friends. How much did Erin have left for herself? Okay, so she had 1, 2, 3 1/9. And then she gave away, she got rid of. What kind of math does that sound like to you? Subtraction. She's getting rid of, she's giving away 1 3/4. Okay, so with subtraction, just like addition, we got to make sure those denominators are the same. We don't want to be trying to subtract boys from piles of onions, right? That'd be the same kind of thing. So we got to make sure that these denominators are the same. So can I turn a 4 into a 9? No. Can I turn a 9 into a 4? With multiplication? No. So the easiest thing is going to be to multiply them by each other. It's the easiest thing to keep track of. It is going to give us a bit of a bigger number, but we're pretty smart. Do it to the bottom, do it to the top, do it to the bottom, do it to the top. Notice I'm doing nothing to those whole numbers. They are going to stay just like they are. So now I need to rewrite it. 9 times 4. 36 minus 1 and 36 equals some number and 36. Okay, so 1 times 4 is 4. 3 times 9, 27. Pause here and solve. Okay, so 36 is already done. So now we're going to do, remember you always do the fraction first, and here's a great example of why. You have 4, they want 27. Not going to work. You're going to have to borrow from this whole number. And if you've already done the whole number answer and have a 2 written over here, you're going to get it wrong because now there's only 2, and I'm going to have to add 36 to here. Whenever you borrow from a whole number, you're always just going to add in your denominator, because that's how many pieces it took to make a whole. So 36, 37, 38, 39, 40. So now this is an improper fraction, correct? But I need to have this many pieces to be able to subtract that one. So it's a lot of math to keep track of. I'm going to write it off to the side here. Oh, I'm going to write it off to the side over here so you can see it. So 0 minus 7, I can't do. More borrowing. 10 minus 7 gives me 3. 3 minus 2 is 1. 13, 36. Now I go back to my whole numbers. 2 minus 1 is 1. A lot of math. I want to make sure that I get that there. And if I look back at the question, it's boxes of granola. How'd you do? Oh, that looks like Granda. There's no way to fix that. You're just going to have to trust me. It says granola. All right, let's keep going. I got to turn the page. If you don't, then keep going. All right. So, number 4. Jada had 1.5 pieces of red licorice. Her cousin gave her 2 1/4 pieces more of red licorice. Then Jada gave 1 1/8 of the pieces to her dad. How many pieces did she have left? Holy moly, that's a lot of fractions. So she had 1.5. Her cousin gave her. What kind of math does gave her sound like? Gave her is addition. Gave her 2 1/4. So then she had some amount of licorice. Oh, I said 1/4, but I wrote 1/2. Oh my goodness, today is a rough day, guys. Magical pen eraser to the rescue. 1/4. Okay, so then she had some amount, and then she gave some to her dad. So when she gives away, that is subtraction. 1 1/8. Okay, so we have 2 problems to solve here. 1.5 plus 2 1/4. I'm looking at those denominators. Those are different, but I know I can turn a 2 into a 4. Actually, why don't you pause and solve just this first step. Just the first one here. Alright, I started giving you a hint. I can turn the 2 into a 4 if I times it by 2. Times it by 2 at the top. Now I have 1 2/4 plus 2 1/4. Let's see. Start with those fractions first. 2/4 plus 1/4 gives me 3/4. 1 plus 2 gives me 3. But then she gave some away to her dad. Pause and solve the second part. Okay, hopefully you looked at those denominators because they are not the same. But I can turn a 4 into an 8 if I times it by 2. Do it to the bottom, do it to the top. Now I have 3. 3 times 2 is 6 minus 1/8. So, same thing, we're starting with those fractions first. So we're going to have some number of 8s. We have 6 minus 1 for 5. 3 minus 1 for 2. Pieces of licorice. How we doing? Only a couple more. We're only going to go to 8. 9 and 10 you can do on your own if you'd like. Alright, number 5. Last Saturday, Michael spent 2 1/6 of an hour cleaning the hamster cage, 3/12 of an hour walking the dog around the block, and 5/60 of an hour feeding the bird. What part of an hour did Michael spend taking care of all his pets? So this pet and that pet and that pet. What kind of math does that sound like? Write the equation, the number sentence, and let's see what you come up with. This is an addition problem. So he spent 2/6 of an hour cleaning the hamster cage, and 3/12 walking the dog, and 5/60 feeding the bird. So this is a 3-part addition problem. So, what shall we do? I'm going to add these a little bit separately, right? We already know 5/60 is 5 minutes. So I'm going to worry about 2/6 plus 3/12. And then I'll come back for this extra 5 minutes. Pause and solve here. So hopefully you looked at those denominators first. You have 6ths and you have 12ths. Those are different. We need to make them the same. Times by 2, times by 2. Now we have 4/12 plus 3/12 equals. Remember on your last skill check, this problem would have looked like this. Equals blank space plus blank space equals blank space. So this would have been what you were supposed to put in there. You put 3/12 here, 4/12 here, 3/12 there, and then your answer here. This will show up on your final test. So this is what this means. You have this problem, you're doing this math, so put it in there to get to the answer. Okay, back to the problem at hand. So we have some number of 12ths. 4 plus 3, 4, 5, 6, 7. 7/12 of an hour. Pause here. How many minutes is 7/12 of an hour? Let's see if you can remember. If not, go back in your workbook and you will find where we did the clocks and 12ths of an hour. 12ths of an hour. Look. It's 5 minutes. So, we were trying to figure out there 7 times 5 for your number of minutes. 5, 10, 15, 20, 25, 30, 35. So, we have this number of minutes and this number of minutes. We need to add them together to get a total of 40 minutes cleaning. Well, I guess he's cleaning and taking care of his pets, but there we go, 40 minutes. Now I gotta flip back to the story problems. There they are. Okay, number 6. Leia was planning to spend 2 1/3 hour with a friend on Saturday, but her mom said she had to finish her chores first. If it took 3/4 of an hour to do her chores, how much time did Leia have to spend with her friend? Write me an equation. Write me the number sentence that matches that problem. There we go. Okay, so she wanted to spend 2 1/3, but she spent time cleaning. Spent. So she used some of that time. So subtraction. She used 3/4 of that hour. So how much time did she actually have? All right, so pause and solve. Looking at those denominators, we can't turn one into the other, so just multiply them by each other. Times 4, times 4, so we have 2. 3 times 4 is 12. 1 times 4 is 4. Minus some more 12ths. It's going to equal some 12ths. Whoa, not 21st. 3 times 3 is 9. Always do the fractions first. Here's a great example. This one is bigger than that one. You have 4, they want 9, which means you have to borrow. Remember, you're always going to add your denominator in. In this particular problem, it's 12. So now you have 1, 12, 13, 14, 15, 16 twelfths minus 9 twelfths is going to equal some twelfths. So 16 minus 9. Okay, I can't do that, right? So 0, now we have 16 minus 9, 4, 7. Okay, now go back to your whole numbers. Don't forget them. 1 minus nothing is 1. So she has 1 7/12 hours. I gotta turn it again. Number 7. Josie walked 3/10 of a mile to the park. Then she walked 2/5 of a mile to Angie's house. Then she walked 1/20 of a mile home. How far did she walk in all? Give me an equation that matches. So, maybe you drew yourself a little picture here. She went to the park for 3/10. Yay! Then she went to Angie's house, and that was 2/5. And then she went to her house, which was 1/20. So this is an addition problem. 3/10 plus 2/5 plus 1/20. Let's see what you do here. Pause and solve. All right. So if I look here, I have a 10, I have a 5, and I have a 20. So either I can multiply both of these to make them 20s, which is kind of the easiest thing to do, then I only have to do math once, or I can break this apart and solve two of these at a time. But I'm just going to do one problem. Times 4, times 4, times 2, times 2. So now I have 20ths plus some 20ths plus some 20ths equals some 20ths. 3 times 2 is 6. 2 times 4 is 8. I'm just going to bring that 1 over. So I have 8, 9 plus 6 gives me 15 20ths of a mile. Now, if you did yours a different way, if you broke it up or did something different but still ended up with this fraction as your answer, fantastic. That means you just found a different way to do it. All right, last one today. The class was celebrating reading week with cupcakes. The red and blue table groups ate 2/5 of the cupcakes, and the green and purple table ate 3/7 of the cupcakes. What fractions of the cupcakes was left? How many cupcakes might there have been? We want to watch that. How much was left? Okay, this one's a little bit more tricky, so I'm going to do a little bit more walking through with this one, with little bits of you solving it. So, the red and blue ate 2/5. The green and purple ate 3/7. So, you ate this much, they ate that much. We're going to add those together, and that's going to give us how much they ate all together. Pause and solve here. Okay, can I turn one of these into the other? No, I can't, so just multiply them by each other. Okay, so now we have 7 times 5, 5, 10, 15, 20, 25, 30, 35. Use your fingers, you have them for a reason. I mean, other than just doing math, but 7 times 2, 14, 3 times 5, 15, some number of 35ths. So now we need to add those together. 9, 1, 2. Okay. Now, 29 35ths. This table ate this much, those tables ate that much. This is how much was eaten. Was eaten. Now, I underlined something in this problem. This question does not ask how much was eaten. This question is asking how much was left. This is a different question. This much was eaten, so 35 minus 29. That is going to give us the sum number of 35ths that was left. That would be what our answer is with this one. Like I said, a little bit trickier than the others. So 5 minus 9 we can't do. 15 minus 9. For 6, 2 and 2 is 0. 6 35ths was left. Okay. The other question is, how many cupcakes might there have been? How many cupcakes might there have been? Well, there might have been 35 cupcakes, with 6 being left over. And there's our 2-part answer. Good work today. Nice job staying focused. Today you have 2 practice pages with your independent work. They're pretty simple, so give them a shot. If you get stuck, come and check in with your teachers, and we'll see you tomorrow, guys. Bye.